This is us 400,000 years ago. Here our ancestors have just mastered fire. Cooking eliminated parasites and unlocked the calories that allowed our brains to grow. Between that first spark and today, hundreds of thousands of years passed slowly. We built our understanding of the world brick by brick. Philosophy, astronomy, mathematics, alchemy, physics, chemistry, and finally computer science. It changed the way humans live so drastically that if you teleported someone from 300 years ago to Times Square today, their brain would likely short-circuit. But here's the scary part. More technological progress has happened in the last 100 years than in the previous 10,000 years combined. This means that our current pace of living is an anomaly. We're flying blind with no historical manual how to keep up this speed. For example, most of us act if the energy was infinite. But the reality is much more complicated than you think. At our current rate of global consumption, proven reserves of oil and gas are projected to last just over 50 years. So the main question is, do we actually have enough resources to keep our generations alive in 50 years? In this video, I'll explain why we must completely overhaul our data centers or AI will literally drink our water reserves dry, how electricity has become the single biggest bottleneck of the AI revolution, why we can't just desalinate seawater to solve the problem, how China cornered the cheap market by seizing control of rare earth elements, and finally, what humanity must do to avoid climate catastrophe before we even reach AGI. Ask yourself, what do you think is the most valuable resource on Earth? Gold, oil, maybe data? Personally, I think it's water. To illustrate the importance, let's just make you a president of some big country for just 5 minutes. So, as the president, you have to deal with issues. And here's one for you. The country's water reserves can only sustain our way of living for 2 more months. 60 days, that's it. So the first thing you do is, of course, you grab the list of where actually our water goes so you can start cutting. You probably think that lists look like this: drinking water, showers, washing machines, and maybe some factories. But of course, when the data comes in, you realize that cutting all the showers in the world won't save us, not even an inch. First, we have to break the water bill into detailed receipts. The first is the domestic usage. The domestic slice makes generally less than 10% of the entire consumption. The industrial slice is a tricky one. It's expected to have a huge water consumption, but some things just don't make sense. For example, it takes approximately 2,500 liters of water to make one cotton t-shirt. That's enough for you to drink for 3 years. Or listen to this one. A single car requires about 150,000 liters to produce. Yeah, the industrial slice with its 20% of the world's total water consumption is big. But it's nowhere near the agricultural consumption, which makes 70% of the entire world's water consumption. And anyways, we're not here to discuss the agricultural part of the water consumption. That's maybe a topic for another video. Today we're here to discuss the new thirsty monster in the industrial slice. Of course, I'm talking about AI data centers. They're warehouses full of hot metal. Every time you ask an AI to write an email or generate an image, thousands of processors heat up. If they get too hot, they melt. To keep them from melting, we pump water through them. Billions of liters of it. By 2027, global AI demand will consume more water than an entire country of Denmark uses in a year. Now I know what you're thinking. We are living on Earth, we're 70% water, so what the fuck do I care? Can we just desalinate our seawater and take it and use it for our purposes? Well, the simple answer is no, we cannot. It's not that simple. And there are two major reasons for that. First, the energy loop. Desalination is an extremely energy-intensive operation. And in that situation, it looks like a snake that's biting its own tail. You need water to make energy, and you need energy to make water. And of course, the second thing, which is also really important, is the toxic leftovers. When you take fresh water out of the ocean, you leave there hyper salty toxic sludge. And of course, we usually just dump it back to the ocean, which suffocates the marine life, and the biosphere is not feeling really good after that. So the short answer for the desalination question is no, we can't just drink the ocean water. But there has to be something else, right? If the desalination is energy intensive and we cannot make more energy to desalinate the water because again, we'll end in this never-ending loop. Maybe we can just use renewable sources? Sounds good. Why not just plug the desalination plant and every AI data center into a solar grid and use it as a renewable energy source, right? Sounds really smart. Well, of course, it's not that simple. And let's start with the way how AI data centers consume energy. We've had data centers for decades. Google, Netflix, Microsoft, etc. But what's the difference between a normal data center and an AI data center? Well, the difference is huge. For example, let's take a Google search. You ask it a question and it just tries to find the answer that is already listed there. It's stored somewhere, you just have to find it. Whereas the AI data centers, they're not just finding the answers, they're literally generating it from scratch. And that's the main difference. Normal data centers use CPUs, but the AI data centers use GPUs that are much more energy demanding. A single ChatGPT query uses approximately 10 times more energy than a single Google search. And generating an AI image uses as much energy as needed for your smartphone to be fully charged. Okay, we just get some context here, but we still haven't answered the question, why can't we use solar panels to power the AI data centers? There are three problems. If the power drops for even a second, you risk losing millions of dollars in progress. So to bridge that gap, you need some energy storage. And to build enough batteries to cover our current AI demand, we'll need more lithium and cobalt and other metals than we are currently mining on Earth. In simple words, our tech is far from being able to create such a big energy storage that can power the entire AI infrastructure for us. The second thing is the infrastructure lack. Even if we had infinite solar power, we have nowhere to put it. Our current electrical grids were built for 20th century. Big, steady coal and gas plants. They aren't designed to handle thousands of tiny, fluctuating green energy sources spread across the map. And the third part is the water energy paradox. Because even green energy has a massive water footprint. Manufacturing the high-purity silicon for solar cells requires washing it repeatedly. A single factory can guzzle 20 million liters of water a day. We're essentially printing our clean energy at the expense of our drinking water. The second thing is the maintenance trap. Solar farms work best in deserts, but deserts are dusty. To keep efficiency up, we have to wash millions of panels with trucked-in fresh water, using billions of liters annually in places that barely have any to begin with. So if we cannot rely on renewable sources, what other sources of energy we can use for AI data centers? In 2024 and 2025, the nuclear renaissance officially began. Microsoft signed a deal to resurrect the infamous 3 Mile Island, the site of America's worst nuclear accident, just to power their data centers. Google and Amazon are pouring billions into small modular reactors, miniature nuclear plants that can be built in factories and dropped right next to a server farm. Why? Well, because nuclear energy is the only clean energy that can provide baseload power 24/7. But even this solution comes with a terrifying catch. Remember our first problem? Water? Nuclear plants are one of the most thirstiest machines on Earth. They require massive amounts of water for their cooling. So by solving the energy problem with nuclear, we're potentially doubling down on the water problem. So right now we're entering an era where governments have to decide whether we are powering the algorithms that run the world or we're giving the energy to our citizens to turn on their light bulbs. Even with all the problems we just discussed, there's another trap. Even if we find the water and we build nuclear plants, we have to have the material needed to build the new AI data centers. And the crucial materials battle is the one that China has been quietly preparing for since we outsourced our manufacturing there. Most of the people think of the chip war as of the battle between Nvidia, TSMC and other companies between America and let's say Taiwan. But the war is actually being won in the dirt, specifically in the soil of the Guangzhou, China. While the West spent the last 30 years outsourcing its manufacturing to save money, China spent those same 30 years buying up the entire periodic table. They didn't just find the minerals, they built the only factories in the world that know how to process them at scale. They're called rare earth elements, but they are not actually that rare. You can find them, for example, in the US, in Vietnam or in Australia. The rare part about them is the processing. As of late 2025, China controls 70% of the mining, but a staggering 90% of the refining. Why does that matter? Well, because without gallium there are no 5G high-speed internet, and without germanium there are no optic cables needed for the AI data centers. So if they really wanted, China can effectively slow down the entire world's AI development. So right now we're facing a three-headed monster: a water crisis, a mineral shortage, and an energy bottleneck. But is it actually hopeless? Well, of course not. But to prevent some climate catastrophes and other sorts of problems before we even reach AGI, we have to stop brute forcing the future and start engineering it. Right now we're using the wrong tools. Using a GPU to run AI is like using a flamethrower to just light a candle. And the future lies in different types of computers. For example, neuromorphic computer. These chips are designed to mimic the human brain. Early tests show that neuromorphic chips can be 90 to 95% more energy efficient than current GPUs for specific tasks. The second thing is that we have to build better AI models that are more efficient in storing, in memorizing, and where we do not have to use this much data to train the model. Also, we need to change where we build. Right now we vent the heat from data centers just into the sky. It's a pure waste of energy. But for example, in Finland, they are turning that waste into a product. Microsoft is building a data center region in Espoo, Finland, that pumps its waste heat directly into the city's heating pipes. This single project will cover 40% of the heating needs of the entire district. I think it's pretty smart. Blowing air over hot chips is inefficient. The industry is moving towards liquid immersion cooling, where servers are basically submerged into a specific non-conductive fluid. This technology eliminates the need for water evaporations entirely. If we mandate this for all new AI data centers, we basically take a huge part of the water crisis we talked about in the first part of this video. The technology to save us already exists, we just have to deploy it. Of course, there are many problems that come with it, but if we want the AGI not to destroy us even before we build it, and if we want the AGI to build a better future for us, we have to really reevaluate our decisions and make smarter, not bolder moves. Thank you for watching this video.